Welcome back to the Science and Engineering Practices Reference Guide for Teachers in Developing College and Career-Ready Students. The next science and engineering practice is a given in any science class. If your experiences have been similar to mine, you realize the importance of being familiar with where your students are in their ability to use mathematics and computational thinking whenever you begin to assist them in the process of data analysis. Hopefully, a better understanding of this will develop as you explore this toolkit, which focuses on Science and Engineering Practice 5, using mathematics and computational thinking. Mathematics and computational thinking provide the tools needed to collect and analyze data, make predictions, and evaluate variable significance in science, and are an integral feature in establishing and evaluating design parameters in engineering. Students begin to develop this practice as they go from recognizing the symbols we use to represent quantities and equating these to the patterns they see around them. By the end of 5th grade, students should be able to distinguish between the attributes of qualitative and quantitative data, take accurate measurements, and organize numbers so that patterns are revealed. The use of digital tools are incorporated in grades 6 through 8, and the ability to apply mathematical concepts and processes, including simple algebra, are emphasized. Students graduating from high school should be able to apply a range of mathematical tools to collect, modify, and analyze data and to suggest revisions to or creation of a variety of models and simulations. Science and Engineering Practice 4, Analyzing and Interpreting Results, and Science and Engineering Practice 5, Using Mathematics and Computational Thinking, go hand in hand. In Science and Engineering Practice 5, students need to quantify and modify data, identify units of measurements and patterns, and create graphs or charts. They must present data in a quantifiably meaningful manner. In this assessment question that falls under Science and Engineering Practice 5, students in grades 3 through 5 must be able to recognize and apply the appropriate computational thought processes in order to come up with the correct answer. Montana teachers identified this NAEP predict motion when unbalanced forces are applied, grade 12 item, as falling within the grades 6 through 8 framework for science education. The students must use their basic understanding of forces and motion along with computational thinking in order to solve this problem. According to the K-12 framework for science education, a firm understanding of the relationship among speed, wavelength, and frequency should be established in grades 9 through 12. Computational thinking is necessary in order to establish this understanding. Another skill established in grades 9 through 12 is an understanding of how elements decompose and the mathematical computations that can be used to determine the approximate age of Earth's materials. In this middle school sample classroom task, students create and revise water cycle models based on flow data and calculations. Classroom sample tasks are found on the Next Generation Science Standards main page under the Resources link in the Implementation tab.